Bismillahirrahmanirrahim. Welcome to another lecture on work and process design. Today we are going to start module 3, that is work measurement. Traditionally, this topic is also called time study. So using the approach of work measurement, we find time standards to perform different tasks. So there are different approaches to work measurement or time study. The most commonly used is stopwatch based time study. So at the end of this lecture, you should be able to understand and describe the need for work measurement or time study. You should be able to use procedure of stopwatch time study to find standard time. So that is the ultimate output of this procedure of work measurement, that is to find standard time. You should also be able to understand some important concepts related to stopwatch time study. That is to divide the job into different elements for the sake of time study or work measurement. You should be able to find the number of observations to be made in order to be confident that the standard time found is acceptable. Then there is an important concept of performance rating. So we'll see how we rate the task that is being performed by a worker. And you should be able to assign different allowances in time study. And once we have found the standard time, it can be used in a number of ways. And generally speaking, the standard time helps us to define different KPIs for the organization. So we will see some of those performance indicators towards the end of this lecture. So you should be able to do basic work analysis based on standard time. So work measurement is the application of techniques designed to establish the time for a qualified worker. So this is important. We are going to find a time for a qualified worker to carry out a specified job at a defined level of performance. Standard time can be defined as the time taken by an average experienced worker for the job with provision for delays beyond the worker's control. So this is the important point, that the standard time is for an average experienced worker. It is not for a super fast worker, and it is not for the worker that is below the average performer. There are several techniques used for estimation of standard time in industry. Stopwatch based time study is most common. That is what we are going to discuss today. Then there is work sampling, predetermined motion time systems, and finally standard or elemental data method. First and second, stopwatch time study and work sampling are based on direct observation, while 3 and 4 are indirect methods. You can find standard time using method 3 and 4 without directly observing the task while it is being performed. So we will discuss PMTS in detail, and we will see how actually we can use it to find standard time without directly observing the worker. So basically this PMTS, these are the databases of times that have been developed over time, and you can readily use them for finding standard time in your case. So once you know the standard time for a task, it has many applications, many very important applications in different organizations. For example, you can set standards of performance and then evaluate the performance of the worker with those standards. And you can use that as the basis for incentive payment. So you can, for example, calculate the capacity of the worker using standard time, and then see whether the worker is producing according to the capacity or not. And of course, there are different measures to to compare the performance of the worker. One of them is efficiency. So efficiency has a direct use of standard time. So you can set standards and then compare the performance of the worker against those standards. You should be able to estimate the manpower requirements. So we discussed a formula to calculate number of workers that was equal to workload over available time. And we saw that workload was actually equal to the quantity that is to be produced multiplied by the standard time divided by available time. So for example, if the worker has to produce 100 products, that is quantity, and standard time to produce one product is 5 minutes. So the workload will be 100 into 5 or 500 minutes. Similarly, standard time can help us estimate delivery schedules and planning the work. So once we know how much time it will take at each step in the manufacturing of a product, we can calculate the total time that is required, that we generally call manufacturing lead time. So the operation time is an important element of the manufacturing lead time, and operation time actually is found using time study. So you can estimate delivery schedules and planning the work at a workstation. And standard time can be used to balance the work of operators working in a group. So a technique that is called line balancing. So once we know how much time each task should take, we can combine different elements so that the work of different workers working in a group or working in a line or working in a cell is balanced. Of course, you could think of other applications as well. So stopwatch-based time study is the most versatile and the most widely used technique for work measurement. This technique is based on measuring the work content of the task when performed by the prescribed method, with the allowance for fatigue and for personal and unavoidable delays. This point is very important, that before actually finding the standard time, the task must be standardized. We can actually use time study before standardizing the task if the goal is to improve the task. But if you are going to set standards for performance, then you should first improve the task using the approach that we have already discussed and then find its standard time. So stopwatch-based time study is especially important for short, repetitive tasks, the tasks that are performed over and over again by the worker. The analyst who studies the job should be thoroughly familiar with it. So this is also very important consideration. So stopwatch time study uses stopwatch. So traditionally analog stopwatch was used, but nowadays digital stopwatch is commonly used, and it is having some features that make it convenient to perform the time study. Such watch permits timing any number of individual elements and also counting the total elapsed time. So they provide both continuous and snapback timing. So we can actually find the time of a specific element simultaneously while finding the total time that is elapsed in that in performing that task. So that is a big use of this digital watch. So you saw some features of this digital stopwatch in the lab, so I'm not going to discuss it in more detail. But this advantage is important advantage, that you can find both continuous and snapback timing. So that is the total time as well as the time for different elements or different cycles. So first you have to define the task to be studied. You have to divide the task into elements if the task is large enough. But if the task duration is small, then it is not actually necessary to divide the job into elements. We have to decide how many times to measure the task. So you have to find n, number of observations to take. Then you have to time and record element times and rating of performance. So in step number 4, you have to do two things simultaneously. You have to use Stopwatch to time the elements, as well as you have to perform the rating. So both these things should be done simultaneously, and we will discuss why. Step number 5 is to compute average observed time. So let's suppose if n was 20, so you took 20 readings, so you have to take average of those. So that is average observed time. In step number 6, you have to find the normal time. That is actually this average observed time that was found in step number 5 multiplied by performance rating. That was actually assigned in step number 4. So that gives us normal time. Then we have to add some allowances to the normal time if we had one element. And if we had more than one element, then we have to add the normal times for each element. So we come up with the total normal time. And then we will add different allowances. So that will be our standard time. So this was our normal time, and standard time will be equal to normal time plus normal time into A. So that will give us the standard time. So that is the step number 8. So if there was only one element, then of course step number 7 is not required. But if we had more than one elements, then we have to find the total normal time and then use step number 8 to find the standard time. So first you have to define the task to be studied. So there are different possibilities. It could be a new job or activity. You have developed a new process or new method. So you have to, of course, find the standard time for that task. It could be change in materials or method of working. So if you have made some changes in the process, then you might be interested to find the new standard time. An operation that appears to be a bottleneck. So you want to see how much time it is taking. And then improve that task. And then after improvement, find its standard time again to see what improvement has been made with respect to time. Need of standard time to introduce incentive scheme. As I mentioned that once you know the standard time, you can set the performance standard and then evaluate the performance of the worker against those standards. Excessive idle time of machine or extremely low output of a machine. So you want to see how much time it is taking now, you can improve it and then find the new standard time. Or to make preliminary investigation to carry out method study. So you could say that this step, this one and this one are quite similar. So there is some problem with the task and you first want to see what is the time being taken now, and then of course make the improvement and find the new standard time and compare the improvement. But the most common actually use of the standard time are the first two cases. Either it's a new process that you have developed or you have improved an existing process and you want to see the new standard time. Now, if there is only one person on the job, as usually is, then there is no choice. We are talking about the selection of worker. But if more than one person is performing the same operation, the time study man may time one or more of the workers. The requirement is that the worker on which time study should be conducted must have necessary skill for the job, have sufficient experience with the given method. He or she should be an average worker as regard the speed of working. He or she should not be too fast or too slow. Be temperamentally suited to the study. So he should not get confused while being observed, because that is a big problem in Stopwatch time study. And the worker being observed should have knowledge about the purpose of the study. So the worker should not have fear that after time study, our rates, the piece rates will reduce. So you have to take the worker into confidence before performing the study. Now, if, for example, there are both male and female workers performing the same task, then you have to take a representative sample comprising both male and female workers. And for example, if the same task is being performed in two different shifts, then you have to take some workers from the first shift and some workers from the second shift. Now, depending upon the cycle time of the task, we may decide to divide the task into elements. Now, if the cycle time is small, then you may skip this step. But otherwise, it is recommended that you divide the task into elements and you time each element separately. So timing a complete task as one element is generally not satisfactory. For the purpose of time study, the task is normally broken into short elements and each element is timed separately. So reasons could be to separate productive from unproductive time. So for example, there might be some changeover time that is involved. So that is unproductive time and the operation time is productive time. So you could separate both. Or for example, the worker might be performing cleaning operation after a certain number of operations. So that is actually not value adding task. So you can separate the value adding and non-value adding elements if you divide the task into elements. It can help to improve accuracy in rating. So the worker may perform some elements faster and some slower. So breaking of task into short elements permits rating of each element separately. So you could improve actually the score of the rating that you are assigning. So worker might be fast in performing some elements and slow in others. So it is logical to have separate rating for both. To identify elements causing high fatigue, so breaking of task into short elements permits giving appropriate rest allowances to different elements. To prepare a file of elemental time that can be used to set times for other jobs. So this is very important point. So for example, if you have performed hundreds of studies in the same organizations, so new task may have the elements that were performed in the previous jobs as well. So you can take the elemental times from previous tasks for the new task, and you do not need actually to time the new, to time the same elements in the new task. So you only need to time the new elements. So that is very important application. And if this is done universally as has been done, then these elemental times can be used in different organizations. So such databases of elemental times that can be used universally are called PMTS. Some elements are not performed every cycle. Analysts can get a better perspective on them. So just as I gave the example of a setup time or some cleaning time, so that is not performed after every cycle. So you can actually address such elements as well. So there are some simple rules to divide the job into elements. So elements should be of as short duration as can be accurately timed. So they should not be too short so that they are difficult to time. Manually performed elements should be separated from machine-paced elements. So this is very important once we are finding standard time for the tasks that are machine dependent. And we will solve one example of such task as well. In that case, you will see that we have to find actually two standard times, one for manual element and other for machine element. And then we have to add both to find the standard time for the task. The beginning and endings of elements should be easily distinguishable. So for example, an element could start once the worker is going to pick the product or when he is going to dispose of the product. So it should be easy to remember. The starting and ending of elements should be easy to remember. Irregular element, those not repeated in every cycle, should be separated from regular elements. For example, if the jig is cleaned off after every 10 parts, cleaning is an irregular element and its time should be spread over 10 cycles. This is also very important point, and we'll see it with the help of examples as well. So far, if you have any questions, you can ask. An important decision in time study is to decide how many times to measure the task, how many times to observe the worker performing the task for which we want to find the standard time. So it is important that enough cycles are timed so that reliable average is obtained. Now, greater the accuracy desired in the results, larger should be the number of cycles observed. That is obvious. The more readings you take, the more confident you are in the standard time that you have found. The study should be continued through sufficient number of cycles so that occasional elements such as setting up machine, cleaning of machine, or sharpening of tool are observed for a good number of times. So that is also important. And if, again, more than one workers are performing the task, you could select a certain number of workers, and it is also possible that if you have found certain N, so say if the N is 60, so you could say take 20 readings in the morning, 20 in the afternoon, and 20 in the toward the end of the shift. So that is a good approach as well. So where more than one operator is doing the job, short study, say 10 to 15 cycles should be conducted on each of the several operators than one long study on a single operator. So this is something that I just mentioned, that it's better to select a representative sample if there are many workers performing the same task. And it is also better to perform the study in 2 or 3 different times of the day. There are 2 techniques generally to find the number of cycles to be timed. We are having statistical methods, and we are having the use of tables. So on the basis of the requirements of the particular situation involved, accuracy and confidence level are decided. So there are 2 important considerations in statistical methods, accuracy and confidence level. Basically, accuracy here means how much error you are going to tolerate in finding the standard time. So an accuracy of 5%, or better to say an error of 5% and a confidence level of 95% is considered reasonable in most cases. So using statistical method, we need to have a preliminary study in which some cycles are timed so that we can find the average and standard deviation. So we could use 2 formulas. This one, N is equal to ZS over AX bar whole square. Here Z is the number of normal standard deviation needed for desired confidence. So this Z is coming from Z distribution. S is the standard deviation of the initial sample. So say you took 10 initial readings, so there would be some standard deviation from that. So that is S. A is the desired accuracy as a percentage. E is E is not used in the first formula. And X bar is mean of initial sample. Or you could use this formula, and numerator is the same, the denominator is different. And here denominator is E, maximum acceptable error in terms of time. So here A is the error as a percentage, and E is the error in terms of time. So that is the basic difference. Now the Z comes from the Z table that is quite detailed, but here are few of the readings from that table. So if you are going to have a desired confidence of 90%, Z will be 1.65. For 95%, it will be 1.96, and so on. So the more desired confidence, the larger will be the Z. And you could see from here that larger is the Z, the larger will be the N. So let's quickly solve a simple example. A time study analyst wants to estimate the time required to perform a certain job. A preliminary study yielded a mean of 6.4 minutes. So that is X bar. and a standard deviation of 2.1 minutes. The desired confidence is 95%. How many observations will he need if the desired maximum error is plus minus 10% of the sample mean or 1/2 minute? So everything is given. So using the first formula, that was Z into S over AX bar whole square. So for a confidence of 95%, Z is 1.96 as we saw from the table. The standard deviation as was given is 2.1 minutes. Now the error as percentage is 10%, that is 0.10, and mean from initial sample is 6.4 minutes. So using this formula, we need approximately 42 readings. And using the second formula, the numerator is the same, 1.96 into 2.1 divided by error in terms of time is 0.5. So using this formula, the N required is 68. But a much easier approach, okay, this question number 2 is for practice, so you could solve it. Here we are given some observations from the initial sample. So you have to find the mean, the standard deviation, and then you have to find N, number of observation, when the error given is 2% and the confidence level is 99%. So I hope you can solve it. So a simpler approach to find N is using tables, and it gives quite reasonable results. So most companies have prepared their own tables for the use of time study people, which indicate the number of cycles to be timed as a function of the cycle time and frequency of occurrence for the job in the company. So here is one example of such tables. So first you have to take an initial sample, in this case as well, and see the average cycle. So for example, if the average cycle time is around 1 minute, something over here, the first column. So from the first column, say the cycle time is 1 minute. And the second thing that you have to estimate is how many times in a year that task will be performed. So for example, that is 20,000. So from where you can actually get this number is from the your forecast, how much you are planning to produce during the next year or during 1 year. So that 20,000 lies here, over 10,000. So 20,000 lies here. So simply you have to take N is equal to 40. So you will take 40 readings. Let's take another example. Say for example, the cycle time is half a minute, every cycle time. So we will be somewhere over here. And the task is to be performed, say 5,000 times a year. So 5,000 is here between 1,000 and 10,000. So you will be taking N is equal to 30. So you could see for other values as well. So the point here is that the larger is the cycle time, at the top the cycle times are larger, the smaller will be the N, that is obvious. And as the cycle time reduces, N increases. So you could notice this pattern in this table. And secondly, you could observe that for the same average cycle time, the N will be large if the frequency is large, and N will be small if the frequency is small. So if the average cycle time is say 5 minutes, but the frequency is say 20,000, then you will need N of 20. But if the frequency is smaller, say 2,000, then N will be 10. And for say 500, the N will be 8. So these are two factors that determine the number of observations that are to be taken. And these tables are generally for a certain confidence level. For this table, it is not mentioned that most of these tables are developed from empirical studies, and most of these tables are for 95% confidence level. And they give quite reasonable results, and they are very easy to use as well. I personally like the use of these tables. Once you have selected the task to be timed and you have found n, that is the number of observation to take, then comes the practical step. That is to observe the task. So step number 4 is to time and record element times and ratings of performance. And important point is that both these things, timing and recording the element times and rating, should be done simultaneously. The rating should be based on how well the task is being performed. It should be based on the speed and the skill of the worker, and it should not be based on the time the worker is taking. And that is a very important point. Rating relates to how well the task is being performed. So it is not related to the time because it is subjective. So you have to observe the task and assign the rating without seeing the time that was spent. So once we have calculated certain, once we have observed certain cycles of a task, you have to take average. So that is the average observed time. So basically there are 3 times that are involved in a time study: the observed time, the normal time, and the standard time. So whatever you are getting from the stopwatch, the observed time, and then based on that observed time, you have to find the normal and the standard time. So you simply add the number of observations, the time that you have observed for different observation, and divide by the number of observations. So that will give you observed time. And I actually call it average observed time because that is the mean. I will be calling it average observed time. Simply the sum of the times for the cycles that you observed divided by number of cycles. So that is average observed time. So that is simple. Now, whenever you are observing this time using stopwatch, you have to assign performance rating. And there are different types of performance rating. What we are talking about is pace rating. We are assuming that the worker is trained on the task that he is performing. He is having sufficient skills and experience to perform that task. So that is why we are more interested in the speed, keeping these assumptions in mind. During the time study engineer carefully observed the performance of the operator. This performance seldom conformed to the exact definition of normal or standard. So it is necessary to apply some adjustment to the mean observed time to arrive at the time that the qualified operator would have taken to do that job. This adjustment is called performance rating. So we are actually adjusting the observed time to the qualified operator, the time that should have been taken by the average qualified operator. So a qualified operator is defined as a thoroughly experienced operator working under customary conditions at the workstation at a pace neither too fast nor too slow, but representative of a pace that can be maintained throughout the day. So it is sort of an ideal operator, but ideal not in terms of pace, but ideal in terms of the skill, the experience, and the conditions that we assume will remain the constant. So 100% rating represents standard performance. A performance rating greater than 100% would indicate that the worker performed the task faster than average, and a performance rating below 100% would indicate a worker slower than average. So the rating is entirely based on the experience, training, and judgment of the work study engineer. It is the step most subjective. It is based on the judgment and experience. So it is subjective, and that is why it is subject to criticism. So there are some practical steps. One of them is that on short cycle, repetitive work, it is customary to apply one rating to the entire study or an average rating for each element. However, where the elements are long and entail diversified manual movements, it is more practical to evaluate the performance of each element as it occurs. You should rate the operator performing while the element is taking place and record either the single or the average rating. You should not actually assign the rating after the task has finished, after the time study has ended, and you are assigning the rating on the basis of the time. That is wrong. So you have to assign rating while the task is being performed. So it is very important that the person observing the task has experience with the class of work that is being performed. So this is just to give you an idea of what is meant by rating. So for example, this is the ideal operator that we are talking about, average experienced operator having the required skills. So he will have a rating of 100. Now we have operator 1 that is too fast. So when we observe him, we find that he is very fast, faster than average. So he will take lesser time to perform the task. So this is the time taken by that operator. Now, if we set the time standard based on this operator, that will be too short a time. That will not be achievable by an average worker. So we have to increase this time. So we are observing the operator and we are seeing that he is faster than average. So we will be assigning a rating greater than 100 so that this time that is being taken by this operator increases and comes closer to the average operator. So we want to increase that time. So that is why we will have a rating of greater than 100. Similarly, this operator, operator number 3, once being observed, we find that he is too slow to perform the task. So the time taken by him will be larger than the average worker. So if we set standard based on the time taken by the slow worker, then that time will be greater than should be taken by an average worker. So we assign a rating of less than 100 to reduce the time that is being spent by this slow worker so that we come closer to the average trained worker. So that is the basic idea that we should be using. So that is the basic idea of rating. So once you have found the average observed time and you have assigned the rating, then you have to multiply the 2 to find the normal time. And if you had divided the task into elements, then you have to add the normal times for each element to develop the total normal time for the task. So normal time is the observed time into performance rating, and I'm calling this observed time to be average observed time because we are taking more than one reading, so we have to take the average. So normal time for each element is equal to average observed time for that element into performance rating. Now, one important point is that if you assigned one cumulative rating, then that is straightforward. But if you assign rating to each observation, then you have to take average of ratings as well. For example, if n was 10, so you took 10 readings and took average of those, so that is average observed time. Now, if for each of these 10 cycles, you assign a different rating, performance rating 1 for the first element and performance rating 2 for the second element and so on up to the 10th element, then you have to take the average of the ratings as well. So you will have to apply, you will have to multiply average observed time with average performance rating to find the normal time. And of course, if there were more than one elements, then you have to add the normal time for each element to find the total normal time for the task. So here is the idea that if you have taken more than one rating, that is, you have assigned rating to each of the elements, then you have to take average of that as well. You have to take average observed time as well as average performance rating and multiply the two to find the normal time. And once you have found the normal time, you have to add allowances to find the standard time. So concept of allowance is very important. And there are two types of allowances. First, let me show you this figure. So there are two constant allowances. You have to assign these allowances, whatever is the nature of the job. One is personal needs allowance and other is basic fatigue allowance. Then we are having a number of variable allowances. So depending upon the nature of the job, you will be adding one or more variable allowances to the constant allowances. So this is the table for different allowances. So you could see we are having constant allowances. There are two constant allowances, personal need and basic fatigue. So you have to assign 5% personal fatigue allowance and 4% 5% personal need allowance and 4% basic fatigue allowance in every case, whatever is the nature of the job. Personal need allowance relates to the personal need of individuals. They have to drink water, they have to go to the washroom and so on. So that is the personal need allowance. And basic fatigue allowance is that the capability of a person to perform the task decreases with the passage of time. It is higher in the morning and it is lesser in the afternoon and in the evenings. So person gets tired with the passage of time. So that is the basic fatigue allowance. And then there are a number of variable allowances, standing allowance, position allowance, and weight lifting allowance, lighting conditions, air condition, and so on. So we will solve a simple example. And so this is the summary before we go to the example, that we are having personal need allowance, time for use of restroom, drinking water, etc., and basic fatigue allowance based on our knowledge of human energy expenditure. So these are two constant allowances. The main important point here is that allowances are given as a percentage of normal time. So that is very important, that allowances are used as a percentage of normal time. So for example, this 5% is 5% of normal time. This 4% is 4% of normal time and so on. So this is important to be kept in mind. And then there are a number of variable allowances. So let's solve a simple example. We have to develop an allowance percentage for a job element that requires the worker to lift a weight of about 10 pounds while standing in a slightly awkward position in light that is slightly below recommended standards with intermittent loud noises occurring. The monotony of this element is high, and we have to include a personal allowance of 5% and basic allowance of 4%. So what will be the total allowance for this job? So 5% personal allowance and 4% basic allowance, they are constant. The person is standing in slightly awkward position. So for slightly awkward position, so the person is standing. The first point is the person is standing. So we have to give a standing allowance. So that is 2%. So total allowance will be 4%, 5% plus 4% plus 2%. There is no allowance for slightly awkward posture, it is 0%, but there is an allowance of 2% for performing the task in a standing posture. Light that is slightly below recommended standards. So we have to see the light conditions here, slightly below recommended value. So there is no allowance to be added for that. And intermittent loud noise occurring. So intermittent loud oral strain. So for intermittent loud noise, we are having allowance of 2%. And the monotony of this element is high. So let's assume that here we are talking about mental monotony. So for high monotony, there is allowance of 4%. The total allowance for this job will be 5 plus 4 plus 2 plus 2 plus 4. So that is 17%. So this is the table by ILO, and it can be used to get the total allowance in a certain situation. Now there are two actually approaches to apply this allowance. As a percentage of job time or as a percentage of work time. So if you are using this allowance as a percentage of job time, then you have to use 1 plus A, otherwise 1 over 1 minus A. So if the allowance is as a percentage of daytime, the second formula will be used, otherwise the first one. So basic formula for the standard time is normal time into 1 plus A. If allowance is given as a percentage of job time, and if the allowance is as a percentage of work time, then the formula is normal time over 1 minus A. So most of the time, the allowance is given as a percentage of job time. That is more common. But sometimes the allowance is given or allowances to be applied as a percentage of work time. So it is a rare case, but sometimes the allowances are not found from this table. This table is for allowance as a percentage of normal time as a job time. But if it is as a percentage of daytime, then the second formula is to be used. So here it is. So this is multiplied with the normal time, or this is multiplied with the normal time to find the standard time. So this is the formula that you should keep in mind. And I hope you remember from where we got it. So we got it from here. The standard time is the normal time plus allowance as a percentage of normal time. So from here, we have derived this formula. We do need to have a time study observation sheet that includes the name of the operation, name of the worker, the name of the time study person, the date and place of study. And there could be other provision like detailed description of the process. And of course, you have to have different spaces for the readings that you have to take. There should be a column for the performance rating, and there should be some space for calculations as well. So let me show you an example of such a sheet. So this is just one of the many possible templates for a time study observation sheet. So there is the name of the operation, name of the operator, name of the department, name of the observer, and so on. It is recommended that the starting and ending time of the study is also mentioned on this time study observation sheet, so that you can find the elapsed time for the time study. It is also recommended to include the workplace layout as well as sketch of the product that is being made. So these details help to get additional information other than the observed time. Then of course you have the elements that you have divided the job into and certain number of cycles. For example, we are taking 10 cycles, then you will add those time to come up with the total time. Then there is average observed time, then the performance rating, and you will multiply the two to get the normal time, and you will add the normal times of all these elements to find the total normal time. And of course, here you can assign different allowances, personal need allowance, basic fatigue allowance, any other allowances to come up with total allowance. So you have this total normal time, you have found the allowances, and then you will apply the formula of the standard time to calculate the standard time. In the next segment, we will solve different examples of stopwatch time study.